Hello students, I am Dr. Navneet KAUR, Associate Professor in Department of Electronics and Communication Engineering, Sagar Institute of Research and Technology College. Today I'll be taking my 8th lecture on subject Digital Signal Processing. The topic of today's lecture is Inverse Z Transform. In my previous lecture, I have already discussed about Z transform and properties of Z transform. Z transform is tool which is used to convert time domain discrete time signal into frequency domain. Now, in this lecture, we will find out about inverse Z transform and the methods to find out the inverse Z transform. Inverse Z transform is used to convert the frequency domain signal into time domain discrete time signal. That means Z transform converts Xn into Xz, whereas inverse Z transform will convert Xz back to Xn. Now the formula for inverse Z transform is given by this expression 1 upon 2 pi j integration over a closed path C xz z raised to power n minus 1 dz, where C is a counterclockwise closed path which is encircling the origin and it is entirely in the region of convergence. This counter C must encircle all the poles of xz. Now, there are various methods to find out inverse Z transform, but in today's lecture, I'll be taking partial fraction expansion method, which is the most popular and convenient method to find out the inverse Z transform. Now, suppose if I have any discrete time signal, which is represented by Z transform xz. Now, it is in the form of a rational function nz upon dz, where nz is the numerator polynomial and dz is the denominator polynomial. Now, nz is given by b0 plus b1 z inverse plus b2 z raised to power minus 2 till bm z raised to power minus m, where b0, b1, b2 to bm are the coefficients of the numerator polynomial. And denominator is represented by a0 plus a1 z inverse plus a2 z raised to power minus 2 till a to the an z raised to power minus n, where a0, a1, a2 till an are the coefficients of the denominator. Here we can see capital M is the degree of the numerator, whereas capital N represents the degree of the denominator. Now, there are few points which needs to be considered while finding the inverse Z transform using partial fraction expansion method. Now, first we have to check whether the given function is in proper form or not. Now, what is proper form? The function is said to be in proper form when following conditions are satisfied. The first condition, that the coefficient a0 in the equation should be equal to 1. That means here a0 should be equal to 1. This is the first condition for this rational function to be in proper form. And second condition, that an should not be equal to 1 and the degree of the numerator should be less than the degree of denominator, that is m should be less than n. That is m, this degree of numerator should be less than the degree of denominator, which is capital N. If this condition is not satisfied, then this partial fraction expansion method is not used and generally long division method is used. And if we want to find out by using partial fraction, then we have to divide the numerator by denominator so that the degree of the numerator becomes less than the degree of the denominator. Now, first step to obtain the function in the proper form is to multiply the numerator and denominator by z raised to power n. That means we will convert the function in terms of positive powers of z. Then we will obtain the equation xz upon z. Now, then we will factorize the denominator and will obtain the roots. Now the denominator will be in the form of z minus p1, z minus p2 to till z minus pn, where p1, p2, pn are known as the poles. Once the denominator is factorized and it is represented in the form of these factors, we will write down the equation in partial fraction expansion form. That is, xz upon z will be written as a1 upon z minus p1 plus a2 upon z minus p2 plus a3 upon z minus p3 till an upon z minus pn. Here a1, a2 till an are the coefficients, and we can determine the value of these coefficients. Now, if I want to find out the value of any coefficient ak, then ak is given as xz upon z and multiplied by that particular factor z minus pk. And the value of this whole expression will be calculated at z is equal to pk. Now, suppose if I want to find out the value of a1, a1 will be written as xz upon z into z minus p1. And the value of this expression will be calculated at z is equal to p1. Whatever will be the value of a1, we will take the value of a1 and we will substitute here. Similarly, we will find out value of a2, a3 till an using this formula. Now, after calculating the values of a1, a2 till an, we will transfer z to the right hand side. Now, we will have equation in the form of z upon z minus a. Now, depending upon the ROC given, we can find out the inverse z transform. If ROC is given as z greater than a, then in that case, inverse z transform is written as a to the power n-un. Because in my previous lectures, I have already discussed that the z transform of a raised to power n-un or minus a to the power n u of minus n minus 1 is given as z upon z minus a, but ROCs varies in both the cases. In first case, ROC is z greater than a, whereas in second case, ROC is z less than a. Now, suppose if ROC is given as z greater than pole a, then we will write inverse z transform as a to the power n-un. But if ROC is given as z less than pole a, then we will write inverse z transform as minus a to the power n u of minus n minus n. So depending on the given ROC, the sequence will be written as P to Pk, where Pk is pole raised to power n-un. If ROC is z greater than Pk, that means for causal sequence. Whereas if it is anti-causal sequence where ROC is z less than Pk, then inverse of z upon z minus Pk will be written as minus Pk raised to power n u of minus n minus 1. Now, we will understand this method by taking an example. Now, suppose if I want to find out the inverse z transform of this xz. Now, we can see this xz is in the form of a rational function and ROC is given z greater than 1 by 2. Now, first, we will check whether the given function is in proper form or not. Now, we know the function is in proper form when the degree of the numerator is less than the degree of the denominator. Here we can see that the degree of numerator is 1, whereas the degree of denominator is 2. That means m is less than n and a naught is equal to 1. A naught means constant term. It is equal to 1. So the given function is in proper form. So now we will move ahead with the partial fraction method. Now, for taking the step 2, we need to multiply numerator and denominator by z square, where 2 is the highest power of the denominator. Now, when we will multiply numerator and denominator by z square, we will get the expression z square minus z upon 2 and denominator as z square plus 3 by 4z plus 1 upon 8. Now, in next step, we will take xz upon z. So, numerator, we can take z common here. So, z will be taken common. So, z minus 1 by 2. Now, this z will be taken with xz on the left hand side. So, xz upon z is equal to z minus half upon z square plus 3 by 4z plus 1 by 8. Now, in step 4, we will factorize the denominator. That means we will find the roots of the denominator. Now, to obtain roots P1 and P2, which are also known as the poles, we will use the solution of the quadratic equation, where P1, P2 can be represented, can be calculated by this formula. Now, after solving, we will get the roots P1 and P2. Now, here we have used the formula for finding the roots of the quadratic polynomial. So, we will get minus b plus minus b square minus 4ac upon 2a. Here b is 3 by 4, a is 1 and c is 1 upon 8. Now, substituting the values, we will get the two values P1 and P2. P1 is equal to minus 1 by 2 and P2 will be taken as minus 1 by 4, which is the result after calculation. Now, in step 5, we will write down equation in the partial fraction method because we have already factorized the denominator polynomial. So, it is z plus half into z plus 1 by 4. So, it will be written in the terms of partial fraction expansion a1 upon z plus half plus a2 upon z plus 1 by 4. Now, in step 6, we will obtain the values of coefficients a1 and a2. I have already discussed a1 will be taken as xz upon z into this particular pole z plus 1 upon 2 and the value will be calculated at z is equal to minus 1 by 2. Now, after solving, we will get a1 as 4. Now, we want to find out the value of a2. a2 will be given by the formula xz upon z multiplied by this particular pole factor z plus 1 by 4 and the whole expression will be calculated at z is equal to minus 1 by 4. So, here we can see this is the expression of a2. Now, after putting the value of z is equal to minus 1 by 4, we will get the value of a2, which will be taken as minus 3. Now, we have already obtained and calculated the values of a1, which is 4, and value of a2, which is minus 3. Now, here we will put values of a1 and a2 in step 7. So, 4 upon z plus 1 by 2 minus 3 upon z plus 1 by 4. Now, we will take xz here and z will be transferred to the right hand side. So, it will be 4z upon z plus 1 by 2 minus 3z upon z plus 1 by 4. Now, this is the step where we can easily find out the inverse z transform of xz. Now, inverse z transform of first term z upon z plus 1 by 2 is equal to minus half raised to power n un. And inverse z transform of z upon z plus 1 by 4 is equal to minus 1 upon 4 raised to power n un. So, here for finding the inverse z transform, that is xn, we will find out the inverse z transform on both the sides. Xz will be taken as xn. 4, the inverse z transform of z upon z plus 1 by 2 is minus half raised to power n un. Minus 3, z upon z plus 1 by 4 will be written as minus 1 by 4 raised to power n un. So, this will be the solution. Here we have calculated the inverse z transform of xz, which is xn. Now, if we will calculate inverse z transform depending on the ROC, say here we have assumed that the ROC is z greater than 1 by 2. So, both the sequences will be causal here. Now suppose if I take ROC as Z less than 1 by 4, that means here both the sequences will be anti-causal. Now in that case, the inverse Z transform will be written as according to the formula which I have already discussed, which will be given as here minus pk raised to power n u of minus n minus 1. So using this formula, if I'll consider ROC as Z less than half, so for this I will write minus half raised to power n u of minus n minus 1. Similarly, for this term, I will write plus 3 minus 1 by 4 raised to power n u of minus n minus 1, because for ROC Z less than half, both these sequences will be anti-causal, and for anti-causal, we will use the formula for inverse Z transform as per anti-causal sequence, which is already given in my previous slides. Now, this is the way of finding the inverse Z transform using partial fraction, which is mainly dependent on the ROC given in the question. Now, this is all for today's lecture. Thank you.